Welcome to the container panel. My name is Cian O'Madeen, CEO at nearForm, and I will be asking all these nice gentlemen as many difficult questions as I possibly can come up with in the next 40 minutes or so. If you want to just start off by way of introduction, you can just introduce yourselves.
Do you want to start? Yeah. Hello. So my name is Azat Mardan. I'm a technology fellow at Capital One. Capital One is one of the top US banks. So I work with in the financial industry. So we have some regulations that we have to adhere to, which makes the job interesting.
My name is Guillermo Rauch, and I'm the CEO of ZEIT. We make cloud deployment really easy to do. Just one command, now.
My name is Kulinski. I'm a product manager at nodeSource, and I've been running containers in Node for multiple years now, so loving it.
Hey everyone, my name is Yunong Xiao. I'm a platform architect at Netflix. I've been working on Node for many years, and also containers even before I knew it, on using Zones and Solaris way back in the day.
Cool. So about 3 years ago, I was talking to a VC tech friend in San Francisco, and at the time people were like, you know, there must be like a Heroku for node.js. Someone's going to build this, and at the time, talking to that VC, like I think a lot of the early PaaS companies were really having problems, right? They were trying to scale. I think the problem was there was a lot of churn of customers and stuff. So, you know, typically like agencies would use a PaaS, right? They build like a website for a big like brand or something like that. You know, reasonable amount of usage, but not going to go hockey stick and, you know, make a lot of money. And then there were a few outliers like you know, some of the early online deal companies ended up on PaaS. And scaled, and you know, PaaS companies make a load of money and stuff. But the ultimate problem is that, you know, once you get to a particular size, you're going to hire your own ops people, and you're going to like go, you know, onto AWS yourself, or start, you know, building your own stuff. So the interesting thing though is, like, you know, since containers really started to take off, all of a sudden PaaS is like being built by everybody. It's back again, like, and like, I guess, like, what is like driving all the new PaaS developments that are happening out there?
I mean, I can talk about our PaaS that we're building. For us, we're building a PaaS for a data access layer on Node and containers. And the main motivation for making it a PaaS, for our perspective, is the primary customers for us are our client engineers, so folks who are writing UI or front-end code, who are not familiar or have the experience or comfortable running a service in production, but still have to be able to run a service in production at the same production quality, which means having the greater reliability and availability as any other app on Netflix. And so instead of hiring, you know, or seeding each team with a bunch of DevOps engineers or systems engineers, instead we elected to build a PaaS model so that these UI engineers can concentrate on writing great front-end code and JavaScript APIs for their backend, but have a separate team and a platform that handles all of the ins and outs of operations.
Yeah. So you asked also why build a PaaS, or why not reuse a PaaS, because you eventually hire ops people and go to AWS. And I think in that question, we have the answer, because notice that nowadays we kind of take AWS for granted. But before AWS, people were buying hardware, creating server rooms, going to data centers, and installing that hardware. So it really has to do with increasing the level of abstraction for what we take for granted as basic infrastructure and basic services of the web and beyond. So I think for us, the answer to that is containers provide a very awesome unit of scalability. But to the user and to the developer, the only thing that matters is the code. You want to write code, you want to launch it, and you want to make it accessible, and you want to make it scale. So the answer is, you want to focus on a PaaS because you want to be as close to the product, as close to the customer as soon as possible. And I think that's why there's a reemergence, because containers are sort of this amazing building block that we can now make this a lot easier to implement, and we can focus and keep elevating that level of abstraction to the point where ideally we only care about the code. No one should worry about where or what kind of instance they're running. Similarly to how your operating system works. When you package an app and send it to the App Store, you don't worry about the type of Mac machine that the person bought. If it's a MacBook Air or if it's a MacBook 12. You want to kind of have that packaging infrastructure, but for the server side, where you just double-click, install it, and it works.
The only other thing I want to add is the fact that so many of these tools, so the container infrastructure and some of the orchestration, a lot of them are open source. The most popular ones are now open source, and so that's lowering the barrier to enter. So if you want to build your own paths, you can spin up Kubernetes and put Deis on top of it, and you have the equivalent of a Heroku clone. Now, obviously, you still have to manage scaling all those servers, but you've got the fundamental unit of having a PaaS in 3 or 4 clicks, and that's pretty powerful.
I might say something controversial, but I really think that the DevOps, the trade as a profession, it should go away. There shouldn't be like a separation. Oh, I am a DevOps engineer. We developers, we should do the deployment, and with tools like PaaS, and now it's become easier and easier in containers, obviously. Why? Well, first of all, it's a communication overhead. If you have a different DevOps team, you need to tell them what do you need exactly, and then they need to go. So you have more meetings, you have more just wasted overhead time. I worked at DocuSign, and I have a great example. So DocuSign runs everything on in data centers, and basically it takes at least 1 month, maybe 2 months before you make a purchase order to get the hardware. You put it in a data center, then the DevOps team will configure everything. With Node, it's a little bit faster, but still. And then at Capital One, we one of the first financial institution embracing public cloud. So 5 years ago, we had 5 data centers. We sold most of them, got rid of most of them, and we moved to AWS. That was very kind of risky because in terms of regulation, regulators don't like having it in the cloud, but actually it's more secure. And now we have access, all developers have access to AWS console, so you can just go create an instance. It takes you like a few minutes compared to my work at DocuSign where it would take you 2 months. So I think with PaaS, and I saw the IBM, they have container as a service, CAS, I guess it's pronounced.
Another ass.
Everything as a CAS, everything as a service, right? So, yeah, so let's get rid of DevOps. Let's make the deployment faster and easier, and let's focus on creating business value, adding features, working on UI, on the stuff that's really important.
Cool. So one of I was listening to a talk from Adrian Cockcroft recently, and he was talking about basically the price of compute is going to go to zero or almost zero over the next couple of years. Like it's just heading that way, and so you've got like different like clouds that are all like fighting on price, right? And every year everything becomes like half as cheap again, and it's like just go down and down, right? Now the thing is like with containers and the open source stuff, the tools for managing your software and your deployments, it kind of makes the cloud providers almost irrelevant. There's really no point of difference, and you've got this like trend where they're all starting to move up the stack, right? And they're trying to find some kind of unique thing, whether it's like AI as a service, or some kind of like packaged up messages as a service, or IoT services and all that kind of stuff. Like, but do you think like ultimately that the world of of paths is going to like make all of those all the big clouds irrelevant. How do we like I don't know, how do we like think about that?
I think it's a really, really good point. Something that a lot of people don't think about is when it comes to deploying applications is censorship. In particular, when you host data on behalf of your users, you can be subject to a variety of different laws and a variety of different subtle forms of censorship. There have been stories of different cloud providers just shutting down an entire customer that itself had tens of thousands of customers because one had a file that the National Guns Association or Rifles Association in the United States had a problem with. So not only are we going to make them irrelevant, I think we're going to make them an implementation detail of our infrastructure and architectures. And we're going to be able to provide a level of service quality that, for example, is not susceptible to this type of censorship, that is not susceptible to downtime. Another example is recently in Sydney, in the AWS area, there was a storm that I think for about the larger portion of an entire day, everyone in Australia that was hosted in that particular data center didn't have internet access. Most of the web services that they depended on for critical business value went offline. So the key answer is don't depend on a single cloud provider. We need to take advantage of the cloud in its generic form. We need to create great APIs. And I think that goes beyond open source because when you use AWS, you really don't care about the code that they're running, nor do you want to run that code yourself. You don't want to deal with routing tables or low-level networking code or Linux kernel upgrades. So it's all about like relying on the right APIs to make sure that you have this really high quality of service. And I think the higher we raise that abstraction bar that I mentioned earlier, the better it is for us because it means lower costs for the infrastructure providers. It means more focus on your side on the application, and it means also more reliability for your customers. At the end of the day, you're going to be able to service them 24/7.
I think I agree with all of this, and I think that the cloud providers themselves are going to be focusing on the APIs that differentiate themselves. So you look at like Google and its Vision engine and voice recognition and those specific APIs, those streaming APIs. Yeah, or Watson, yeah, from IBM, right? So those APIs are really going to be the things that are going to drive those cloud providers. In the meantime, us end users can take advantage of the fact that cloud computing is basically going to $0, and same with disk storage. So, and I think having tooling that allows you to roll out across multiple clouds gives you the redundancy to handle outages in any one particular data center.
Cool. So like just on the, I guess on the standardization side of things, you know, is there going to be like a standard for containers that everybody agrees on in any kind of a reasonable time frame?
I think the short answer is yes, but it depends on what you define a container as. So I think we're already seeing process at an open standard definition for what the packaging of the code inside of a container. And so we're seeing Docker and CoreOS and Rocket and all the players sort of agreeing, okay, this is sort of what a container is, and this is the API for that. The higher level abstractions, like the registry, can you push and pull from a registry? Is that going to be an open standard? Jury's out on that. When it comes to orchestration, there should be consistent orchestration APIs? Maybe. But I would also argue that if you look at, if you compare like Mesos versus Kubernetes, they're focused on different end users. So Mesos is very much concerned about getting incredibly efficient bin packing, making sure you can get the most buck out of your servers. Whereas Kubernetes is much more focused on the developer experience. What's it like being a developer deploying to the cloud? And so they have different purposes. So should they have a common API? I'm not so sure.
I think one of the most awesome things we've standardized on in an ad hoc way is that each container represents one process. I think that's a really big victory because if anyone here has used Go and their cross-compilation and the single binary approach of putting everything statically into one process or alternatives in other programming languages, it's really awesome to have a unit that is completely contained and self-contained and reliable, that is easy to share as well. So I think it's awesome that all the competing standards for or implementations or approaches to containers have elevated this idea to the point where like now it's commonplace to think about, oh, a container is a way of managing this one process. So I think that's awesome. On the other hand, there's a story of composability that is interesting, and it has to do also with scheduling. So how do I take this process, and together they do something really interesting? And I think Rocket has an advantage there because they don't rely on you also dealing with a registry and all of this. They use the file systems APIs. The output is a file that represents your container. And I think it's a very clean, Unix-oriented approach to thinking about containerizing. Kind of like when we thought about static binaries and you package your entire application into one binary. This idea that you can package everything, including all the base images and the choice of operating system and dependencies and packages all into this one format. And then how you distribute that is up to you. There's not one registry. There's not even a need to host a registry. So something that also comes with containers is a lot of overhead, even in terminology. Now you have to operate a registry, maybe a private or public registry. Then you have to pull and push. For a lot of beginners, it's kind of confusing why they have to use GitHub for the code, but then they have to have a separate registry for the images. The approach that we take is you give us a Docker file, and we execute it in the cloud. We build it there. We think that the resources of the cloud will always be exponentially greater to accelerate builds and to produce the resulting container compared to your laptop, or even to compare to handheld devices or tablets. I think a lot of us here are used to this idea of we have really powerful laptops and computers in our offices, but think about the idea of building a container directly from a mobile platform or a tablet, kind of like the Swift playground. So our vision is you give us instructions in the form of Docker file, or you give us the Rocket AC build instructions. We build it on your behalf, we launch it and scale it.
The containers is not a new technology per se, right? It was like around 10 years ago, but the Docker really kind of popularized it. And it's always interesting to see, I was relatively early with node.js, so it's always interesting to see how those standards evolve, like in terms of interfaces and kind of common things when you have a lot of fragmentation, but then they converge, and then at some point they might fragment again. So some people might even argue that Dockers and containers, they're now complex. And we need something simpler, maybe like AWS Lambda serverless technology, right? So I think in the next 2, 3, 5 years, I don't know how long, but we will see even more good stuff happening.
I think it's important to sort of point out what Docker isn't, and it isn't orchestration, and it's not the actual operating system infrastructure that lets you run virtualized environments without a hypervisor. It's a tool chain, and it's tooling and registries and a packaging format, right? So if you want to run containers, whether you use Docker or something else, I think it's good to have a common base container format that everyone can interoperate with. But when it comes to orchestration or even registries or the substrate that actually runs the containers themselves, it's good to have choice. And I think healthy competition will drive along the technology as well. And so it'll make the environment and the ecosystem better for everyone.
So in terms of, I guess, Node.js and containers are like, I think I saw a blog post recently where they were saying they were like ice cream and chocolate or something together. Like it's like really, really nice mixture. Are you guys seeing like, when we started a number of years ago, the kind of the thing that everybody went to first around Node.js was like that we can put like this API layer on top of all our old stuff and repurpose it and then serve it up on the web in new ways, and it was like the beginning of migration away from older software, and that was a kind of sweet spot, right? And the thing, I guess when we started, we were hoping that we'd get to a place where people would build entire systems right down to the back end in JavaScript. So are you guys seeing, I guess, are you seeing that? Are you seeing like full stack JavaScript applications containerized out there?
I think Initially, a few shops tried to do that. They wrote JavaScript and Node services for their entire ecosystem. Right? Uber is a good early example. At Join, we did the same thing. But I think as the platform's gotten more mature, it's really found a niche, which is sort of the back end of your front end. Right? It's really, really good at serving up the web and APIs on the front end. But when it comes to like compute-intensive operations, it might not be the best choice. So the good healthy marriage of containers for Node or for any technology is that it lets you easily package something immutably and run it anywhere. So you can run it in the cloud, in production, or in test, locally on some developers. But desktop, anywhere you want, and that makes developer productivity and ease of management and deploying these applications much easier. So instead of having to figure out the 16 different versions of Nginx and Apache or whatever else that you're running and MySQL, you can package them all up in one sort of Docker image and deploy that. And you know that whenever you deploy the same image, because it's checked into the registry, you're always getting the exact same bits. And that's incredibly helpful when you're running a distributed system and trying to make sure that you're running all this stuff reliably.
So this is great. I am giving a talk tomorrow. So by the time that we're done with this question, we can probably be done, because my talk tomorrow morning is containers and Node go together like peanut butter and jelly. And I think, not to go too long, but there's really three things that both Node and containers excel at, and that's performance, it's packaging, and it's scalability. Each one is self-contained, so with Node you're using NPM, you're installing, you've got explicit dependencies for your Node module or for your Node application. With a container, you've got a Docker file that specifies exactly what's going in there. In terms of performance, both start up incredibly quickly, right? So Node is fast to start, so are containers. You don't have to wait for a whole VM to come up just to start a new container. And then scalability. This gets back to what Guillermo talked about one process per container. Node scales on a per process basis, so do containers. And so they fit very, very nicely together for that reason.
Going to your point as well, Node is, and I just gave a talk about our approach to microservices, and I touched on this point specifically. Boot up time is very critical, specifically to elasticity. If you want to launch many, many copies of a process and you want to do that very, very quickly, you can spend a lot of time warming up a virtual machine, for example. So I think when you work on building that image, you also want to worry about that boot up time of that last mile, which is everything could be packaged in an image, but if the last step doesn't happen very quickly, then you're back to this, slower to scale scenario. Something to consider too that Node is really good at is reproducibility, provided that you use NPM in a certain way, right? Provided that, for example, dependencies are not changing a lot over time and things like this. So for a lot of people, if you write a package.json file and you run npm install and you run npm start, that's the end of the story. For other people, maybe not, because they have very complex dependency trees that change over time. So you always have to think about what are the best ways to package my code in such a way that in the future, the next person that runs the build doesn't have a problem. Because even though you have an image registry, if the instructions are, for example, fetching something from GitHub master when that image is being built, then you have a very brittle setup anyways. So just because you have a cache of the end result of that image doesn't mean that you're going to have a great experience later on, because those instructions that you set up in your Docker file or those dependencies that you set up in your package.json yield a very different result over time. And it could be a security hazard as well, because we've seen it with the scare of left pad in the JavaScript community, where you run npm install again, you think everything is fine and dandy, but those things that change can result in a security vulnerability. So at the end of the day, it's all about thinking about what are these ways of containing my application in a way that's completely reproducible. And this is why I think Jekyll has become so popular for building websites, is because the output is this really solid combination of produced HTML, CSS, and JavaScript that is extremely easy to scale, because you put it in front of a CDN and your website scales very easily. So what we're trying to do now is, can we provide that same experience of you created this recipe and you have this target, and now we can put it everywhere in the world and you don't worry about the operations of it, just like you don't worry about the operations of a static file hosting or the files being close to the user when they request them from a certain geographical area.
So we're talking about full stack and containers, right? So my experience with full stack, completely full stack JavaScript, Storyfy, and that was beautiful. So at least my brain thinks 10 times faster, maybe more, when I have this one environment. And someone mentioned for startups, it's very important to have that ability to iterate fast. And when you have one language, it's basically amazing. You can achieve more in a shorter amount of time. And now, I think we also forgot to mention microservices. So I think microservices and this whole shift from monolith to microservices, I think it helped node.js, and also by using containers, basically you encapsulating those services can be very independent of each other. So without the microservices and containers, probably it would be much, 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 much harder to convince your company, especially a big company, to basically re-implement the Java monolith. But right now, everyone loves microservices, right? So you just take piece by piece, endpoint by endpoint, put it in a container. You can use Node, you can use Go, maybe a new language will come up by the end of this panel.
Yeah, we've seen this a few times with enterprises that are trying to get away from like a monolith. And microservices is actually...
You have a book on it, right? It's your company.
Yeah, in a month or two or something. But it's actually can be viewed as a migration pattern, like similarly to what the guys did at Walmart a few years ago. Put an API in front of something and then start like taking bits and building them somewhere else. So and that's actually an interesting insight. It gives the architects a way to retain the value of what they've already built while starting to move fast again, and that's the kind of core thing. Just on the whole area of monitoring, and you've got lots of like Node.js microservices. Like what is your take on what to monitor, and what should people be really looking for? Outside of like CPU burning out or network requests taking a bit too long and stuff. Like what other things do you look at?
Something that's really important when you're working with microservices is understanding, first of all, when errors occur, what was the context of that error? Was that microservice call one that an API client made directly? Or was it made by another microservice, and was it made by another microservice, and was it made by another microservice? So distributed tracing, understanding the flow of data inside microservices is a really big concern. Another one is, like I mentioned earlier, boot up time and reproducibility in the creation process and build process of that microservice. Another one is, and this is a point that I just made at my previous talk, is to the consumer, it needs to appear like it's a monolith. And to the developer, it's a sweet, small microservice distributed system. Why do I say this? Because if you built an API server that serves your customers over api.stripe.com, and then you document it all in one page, and then you have a Node.js client that takes care of interacting with all the endpoints, and there's one cohesive authentication strategy, then that appears to the end user or consumer like a monolith. And that's great. You don't want to change that. You don't want to change that because of that user experience. You don't want to change it because of performance. If I establish an HTTP2 connection to your API server, I don't want to talk to 10 different IPs or 20 different data centers or 100 different subdomains because you built a microservice, decided to build microservices. So in that sense, I think a lot of people conflate and create sort of a false dichotomy between monoliths and microservices. The same goes for front-end applications, actually. When you go to yourcompany.com, you don't want to have, you probably want to have an infrastructure in your backend and the way that you set up your pages or your subsystems in such a way where you don't have a gigantic single folder with every single concern of your company. You want to sort of split that up. But for the end user, they don't want to log in to like 4 different subdomains or 3 different services just because you sort of split that up on a very basic architectural level. So if you think about a lot of like really big companies, they've messed this up. They've created this huge mess of services that they provide without a cohesive authentication layer. They've even added the burden of multiple logins because they can't share the cookie across all their subdomains, and it's a mess. So the bottom line is you want to build with microservices, but to the end user or developer that's consuming your API, it feels and looks like a monolith.
I think in terms of performance monitoring, so if I'm building out a new container-based architecture, I think there's multiple layers that you need to have visibility and insight into what's happening. You know, at the very lowest level, you have probably a cloud provider. So you want some information about the cloud provider. Is your cloud provider healthy? Which data centers are up? Which ones are down? Where can you scale? Where can you not scale? And if you're running across multiple providers, you might need to know about different providers. The next layer is the host level. How is my host doing? Is it having disk problems? Is the CPU, is IOStat overloaded? Right, so there's sort of that layer. Then there's the container level. What is my container doing? Each container in each C group, how much CPU is it using? Memory, network, that sort of insight. Then if you're running whatever language you have inside that container that you've built your code in, you know, if you're using Node, you probably want some Node-specific insights. What's V8 doing? What's libuv doing? And then, yeah, garbage collection. And then the next layer up is, you know, as you talked about, was sort of the distributed tracing. As you've got different services, how do your services interact together? And what's the request lifecycle through that? And I think you need to glue all of those different pieces together to have a complete picture of what your infrastructure is doing.
Yeah, just to echo what Raj just said there, that's a really great take on performance and metrics. With any application, I completely agree, I think. You have to be able to look at the stack, bottom all the way to the top to see exactly what's going on. One thing I would add with Node specifically, though, that we found, you know, just one anecdote that we found really useful for Node is checking the request queue depth. So, you know, because everything's event-driven and there's a queuing model, when you've got a lot of events in the system, maybe there's a retry storm, so you've got thundering herd issues. There's a bunch of requests in the system. That's often a really good early indicator of something wrong that's inside the system. And so being able to monitor for that, alert on that, and if your request queue gets above a certain number, to scale more instances or to start dropping requests on the floor to avoid retry storms is really helpful. And we've seen that, you know, we've implemented that actually, you know, a year ago, and like 2 weeks after we implemented that, we got DDoSed, and because we had this sort of mitigation around retry storms, that actually helped us really survive that. And the other thing that I would add is getting good visibility into these metrics. So you may be collecting and publishing all of these metrics, you know, kernel metrics, page faults, all the way up to, you know, request latency, and you're using some sort of Dapper-like thing to do distributed request tracing. But if you don't have good tools and visualizations for developers to use them, they often won't. And so in critical situations, they won't be able to use them. So collecting the metrics is great, but also providing really good usable interfaces to be able to visualize, run analytics, maybe have some smart ways of alerting and monitoring around these metrics is really good too.
Yeah, I will add one thing to that is we want to be alerted primarily, because when we build a lot of dashboards that provide a lot of data and graphs, it's really very difficult for people to make any sense of what's going on. Primarily because the data of a problem is scattered among several dashboards. But the other one is like, no one has a lot of time to stare at dashboards all the time. Or if you're staring at a dashboard because you get an email that your website is not working well, then you have another problem, which is you're not being proactive when problems occur. So I think this is where the whole chat ops, Slack, chatbots, chat DevOps crowd is making a lot of progress, because you really just want to get notified that something might be going in the direction of going wrong, or have different levels of escalation. And the bottom line is you want to be notified. You don't want to have so much visibility and so many dashboards that you never end up doing anything meaningful. And I think a lot of that has to do with the user experience. It has to do with the operation of the backend. For example, we sit at the proxy level, so we understand how long your processes are taking to respond. And based on that, we can alert you that, look, you've dropped the quality of your service significantly. And then you can look at all the interesting metrics. But it all starts with a system that really understands what are the parameters to monitor, to understand that something is going wrong?
Yeah, so to add to that, we usually just focus on a few very key metrics as sort of the canaries. So when one of these metrics has an issue, like there's a streaming drop or something like that, then we immediately know there's something wrong with the system. I will say that like having access to metrics is always good. So having too much information obviously leads to paralysis, but being able to get that information whenever you need it is incredibly helpful. So you go from, hey, I know there's some health issue with my website, whether it's highly latent requests or a request drop or a high amount of errors, but to be able to dig in and figure out where that's coming from and ultimately drive the root cause, that's where that last mile is. That's where the rubber meets the road, knowing you have a problem to fixing the problem itself.
So speaking of the dev dashboards, I will plug our open source project. If you go on GitHub at Capital One, you will see Higia. It's an open source free DevOps dashboard. And what I really want to see in like the next evolution, I mean, PagerDuty it's cool. Some people say like, oh, make your developers wear pagers and wake up at night so they will drive better code. But what I really want to see in like the next evolution of monitoring is the performance monitoring as well. So like each commit should be tested against the performance, and it should tell you, okay, is your code making your entire application or service slower or faster? Because most of the times you just test it like once, and then you don't know if your application becomes slower or faster, right? Usually it becomes slower, of course. So I think that's one metric I really want to see in all the services.
I agree, and my recommendation for this is do performance testing that performs end-to-end actions. So we use, for example, browser simulation to perform the same tasks that people would perform, or we run the same exact process, including sign up and login, that the user would perform, and then we measure that as opposed to, for example, focusing on the mean response time of API calls, because then you don't get the complete picture. So you start with the high-level performance metrics, and then you go all the way down, and perhaps it ended up being one faulty microservice that had a particular problem in that machine or that network. But it all starts with thinking about performance from the perspective of your end user.
I could actually add one more element to that stack, and some I think quite a few companies are out there doing this, which is having business metrics against your system when you're doing like continuous delivery. So the idea that you update your shopping cart, and if the number of average transactions starts to drop, then you like instantly roll back and stuff like that. So it's an interesting kind of take on things. It's the next level up, yeah. It's like, it's not, is my system going slow? It's like, is my system like making me less money or more money?
Yeah. A part of that also is deploying to a subset of users. So deploying to 10% of your traffic before you commit to 100%, for example, so that you can distinguish the metrics on a subset of the users before everyone or the rollout completes. No, but we are actually thinking about just a flag that you pass to the now command, where you target when you create an alias, you pass a percentage. So just starting with a very simple percentage can be very useful. Maybe more sophisticated examples would require targeting a certain demographic area or a certain person or certain type of business user. But even just starting with a subset of the traffic is a very, very useful thing. And we're working on a flag for doing exactly this.
Yeah, so just to get back to Ross's point, which is that, usually speaking, when there's a problem with your service, generally speaking, something's changed, right? Like, did I make a push? Is one of my providers having issues? And like I said, having some key metrics, for us, one of them is SPS, which is the number of streams that have been started. As soon as we see a drop in that, the first thing we ask is, has there been any code pushes? And if there is, then we immediately roll back, right? Because again, customer impact is the biggest deal for us, for most companies out there. So your first order of business should be to restore your service, and then the second order bit is to actually figure out what's going on and how to fix it. But yeah, having a good way of consistently being able to tell whether that's number of requests or what's in the shopping cart or SPS or whatever it is, to really have that one metric to measure the healthiness of your system and whether customers impacted is really, really key and powerful.
Just in terms of, in a microservices world, having like multiple revisions in production at one time, what's your take on how do you manage all the microservices at different revisions at one time?
So our approach to deployment is immutability. Every time you deploy, you get a new URL, a new microservice. And that's sort of your staging point, because it's not impacting your traffic directly. There is no overwrite of your production deployment. So you can stress test, for example, your service while it's in this staging period. You can try and measure that individual URL. And then when it's ready to go to production, you change the name of it, and it does a zero downtime reload by just proxying all the requests to the new destination. So we sort of take this ambitious approach of unifying the development, staging, and production under one system. And the way we do that is each deployment gets a new URL. There is immutability at that level so that you never are actually messing with production traffic directly when you deploy.
So I'm a huge fan of canary deploys. So doing, and a lot of this depends on having excellent tests for your applications. Not just unit tests, but integration tests. And you mentioned that, right? So being able to fully, when you make a change to your code, you want to have complete confidence, or as best as you can, that if you were to ship that, it wouldn't break anything. And that's a really, really important, that all of this discussion about containers and scaling and all that sort of thing relies on having extensive, comprehensive tests. But in terms of the deploy, I like to use canary deploys. So once something's gone through our build process and we've tested, we've done unit testing and then end-to-end testing of that particular service, we'll then roll that out to a very small subset of the instances. So if we've got 100 instances of a certain application that are running on version A, we're rolling out version B, we might roll that to 1%. And we can then adjust a slider and say we want to go 1%, 5%, 10% while watching these metrics. If you're really fancy, that whole process is automated. So you start rolling it out, and if you start to see business intelligence crash, then you quickly go, oh, go back.
I think a great example of using this approach of canary and also traffic in certain percentage of the traffic basically redirecting is Walmart. They're famous for deploying new node.js services during Black Friday. So in US, Black Friday is like the biggest shopping day, the biggest shopping event, and that's actually better for them because they have so much traffic, so they just take a little bit and they start deploying, and pretty much all of their deployment using Node.js went successfully. And one word of caution from being a developer, and don't have too many UI tests. It's it should be a pyramid. So at the bottom you should have unit tests, and at the top you should have UI tests. So my opinion is that you should have less UI tests than your unit tests, because UI tests tend to be more flaky, and you tend to iterate more on the UI part. So
just before we finish up, are there any projects, products, open source things that you've seen recently that you'd like to kind of plug or tell people to use?
We built Micro, which is the easiest way to create Node.js microservices, because you export a function that takes in a request and response, and you can return an object and it gets sent as JSON. So it's basically the easiest way to write an HTTP service. And on top of that, we transpile support for async and await on the fly. So until it lands on, it's landed on V8, it has not on Node yet, but we use the fastest transform that we've found to, on the fly, very quickly, without setting up Babel and all that, we add support for async and await, which when it comes to writing business logic for microservices, not dealing with callbacks is a huge advantage. So check out Micro on github.com/ZEIT.
So one of the things that I've been experimenting with a lot is shifting my microservices away from REST APIs to streaming APIs, or using a form of message bus. And I don't want to be a message bus expert, and a lot of them require extensive experience on how to set up and manage and how to do clustering, and it's just like a whole other world. And I've been really impressed with, there's a new message bus system called Nats, N-A-T-S.io. It was originally built by the folks at Apcera, which they run their own on-prem cloud stuff. It's really impressive. It's got good node integration, and I've been using that for a lot of side projects.
As you guys probably know, at Netflix, we release a lot of our own software as open source. So one of the biggest things that I think we'll eventually release open source sometime is our container orchestration engine. So this is called Titus, and it builds on top of Mesos and ECS and gives us a way to reliably schedule and manage containers in production on AWS. And it's, without this, we wouldn't be able to run containers today. A couple other things that sort of were open source node software that we use quite a bit. We heavily use Restify, which is a node REST framework, and for the reasons that we talked about earlier, which is performance and metrics, right? It gives you full visibility into the state of your application, and without that, if it's just a black box, then it's impossible to debug. The other thing that we've started to use and play around with for our new stack is something called Reactive Socket, which is a fully multiplexed framing protocol over TCP or WebSockets or whatever it is, and that's all open source. That's being done in the open in collaboration with a bunch of other companies like Facebook. So check that out. That's just reactivesocket.io, and there's a node. We're actively working on a node library for it as well.
Well, there's so many great open source projects and services. Definitely now, it's one of my favorite tools for easy deployment of Node.js projects. Cloud Custodian, check it out if you're working in a large enterprise kind of environment. You have a lot of cloud instances, so to monitor, manage them, make sure you're not spending time. Cloud Custodian will kind of clean up those instances. And lately I've been playing with React and Relay and GraphQL. I've discovered Reindex, which is GraphQL as a service. And basically it allows you, instead of using REST, so REST is kind of old news now, so instead of using REST, you just manage what data you need on your front end by using GraphQL, like a query language. So it's very, very amazing. You don't need servers.
Yeah, and to that point of GraphQL, we might be switching away from microservices to microschemas, because you still need that sort of separation. You don't want to conflate it and create like a gigantic API server. But this is a very interesting point that if we switch away from REST, it has to be because we're getting better performance characteristics for the end user, and I think GraphQL is very promising in that sense.
So I have a plug as well. There's a project that a friend of mine, Peter Elger, is working on called Fuge. It's a set of developer tools and basically solves the problem of building microservices on your laptop. So you can basically boot everything up from one terminal window. He's integrated the Chrome dev tools in there as well, so you can actually freeze in stop a microservice and step through the dev tool side of things. Yeah, it's good. It just makes things fast.
Fuge?
It's called Fuge. So he's originally a nuclear physicist, so a lot of the stuff he does is like nuclear related physics stuff.
To that point of having everything in one place or launching everything in one place, if anyone here uses Hyperterm, the terminal we launched, which is built on web technologies, we're soon merging in support for splits. And something I'm really excited about is that when you're working on your projects, well, obviously a lot of people here probably use split panes on terminals, but also because our terminals can launch web views. We're working on integrating, for example, and easily launching the dev tools for your project on one split, the web browser of hot code reloading that you might do on your front-end code on another split, and then for me, VI on the other split, and it's like heaven for developers. So stay tuned to releases that we make there, because this is sort of our longer-term vision. And finally, the last plug is some of our people from our team are here in the Netherlands, and we might have a little meetup at a venue undisclosed as of yet. But if you follow me on Twitter, I'll probably send the Eventbrite meetup link at some point. And I'd love to for everyone to come and hang out and just ask questions or drink Heineken. I hear it's a big thing. So.
The only place in the world you can drink Heineken where it tastes nice. Just big thanks to all the guys. Thank you for coming along and talking today. I have some notes on the things, the projects you're talking about, so we'll put them up on Twitter later on. And yeah, thanks very much, everyone.